Hey guys, so in this video I'm going to talk about TensorFlow sessions. So a session is basically an environment in which operations are executed and tensor objects are evaluated. So operations need to run in a session. So most of the time you will run it like this with no input arguments. And this is an example of how to use sessions to run operations and evaluate tensors. So let's take a look at this example. So this first part is about building the graph. So there's this tensor A, which is going to be a constant tensor of 5, and there's this tensor B, which is constant and it's equal to 6, and this tensor is multiplication of A and B. In here we are creating a session to be able to run its operators and evaluate its tensors. So our objective over here is to evaluate tensor C. So to do that we need a session, so that's why we did this. Now that we have this session, we can run to evaluate tensor C, and the result is going to be 5 multiplied by 6 is going to be 30. So let's do this in Python. Alright, so let's save it somewhere. Let's say, what do you call this one? Session example .py, and import TensorFlow as TF. What else do we need? So we need to build the graph, and let's build the graph is equal to tf.constant of, let's say, 5. B is equal to tf.constant of 6, and C is equal to A multiplied by B. Now that we have this, we can create a session. With the cap S, and now we can evaluate tensor C. So this should print says return to evaluate tensor C. We will get back to this run function later on, but for now what you need to know is that this run will evaluate to compute. This run will be executed to evaluate the value of this tensor if you give it a tensor, and it will return the evaluated value. So eventually it should print out 30. So let's try it in terminal. I'm going to need the directory for this one, so I need to look for this. Yep, this one. Alright, so right click properties, and this is the directory. I'm going to need it over here, Python, paste that directory, and then what was the name, session or something. If you hit tab it will complete it for you, and if you hit enter it should give you 30 as an output. Alright, looks good. Alright, so we need sessions to be able to evaluate our tensors to be able to run our operations. Alright, so What else do we have over here? So sessions, they may own resources such as variables, queues, and readers, and also they may take up some memory. So it is important to release these resources when they are no longer required. To do this, we have two options. The first option is just using this close method. This is this example for using close. So we have created this session and then we have used it to run to evaluate some tensors or run some operations, and eventually we close this session to free the resources. So the second method is using context manager. So to use it, to use the context manager, you should go like this: with tf.session as sess. Now you can run. So in here you do not need to close the session. Alright, so these are the two methods that you can use to close sessions. Alright, tensor.eval. So we know how to evaluate tensors using sessions. So this is one way of evaluating tensors, and there's another way over here. So in here we are using this with statement. So we've created our graph, and then we've got our session, and then we use this with statement. So my session as default a.eval. A is my tensor, and then after that we can close the session. So let's do this in Python. Tensor eval. So we don't need this one anymore. I'm just going to close it. Let me save this one as tensor eval.py. So import Tensorflow as tf. It's a fairly simple graph, constant of 3, and then the session. And then with as default a.eval. Let's say print a.eval. Now in here should be like this, and indentation is important. This indentation means that this command is using this context, so it belongs to this with statement. Now if you do not indent the next line, it means that it's now out of the context. Alright, so now I have to close the session. This is it. So this one should give me 3 because this is my simplest possible graph. Alright, so let's do this over here. I know that this is my directory. Now only thing I need to do is just hit tab maybe. No, it's not giving me suggestions. Alright, so let's see. This is my file, tensor_eval.py. Right, so 10. Now hit tab. Looks good. This should give me 3. Alright, an error. Alright, session object has no attribute as default. So this is as underscore default. Let's redo this. If you hit up arrow, it will give you your previous commands. Now I'm just going to hit enter. Alright, so I got my output, my desired output, which is 3. Right, so this is how you can evaluate a tensor using eval function. Alright, so let's go to the next slide. Alright, so this is we've already encountered session, how you call it without any argument and it will give you a session, but there are some options over here. So we have 3 arguments. Target is the engine and graph is going to be the graph that the session will use to run. If we have multiple graphs, we need to specify it. If you don't specify this, it will use the default graph. If you don't specify this, it will use the default engine. This one is going to be some configuration options for our session, which we are not going to cover for this video. If you are using more than one graph in the same process, you will have to use different sessions for each graph, but each graph can be used in multiple sessions. Running a session. So to run a session, you call its run method. So this run method takes some arguments. The first one is going to be fetch. This is it can be a single element of the graph or a list of elements of your graph, and this element can be either a tensor or an operation. So if it's a tensor, this function will return its evaluated value. The optional feed_dict argument allows the caller to override the value of tensors in the graph. I'm not going to cover options or run metadata as they are still experimental and are of limited use at this time. So these are some examples of how to call the run method. So this area is creating the graph. So the fetch can be run with only a single tensor, and that's how this one is being run. But you can also give it a list of tensors, and the output will be a list of evaluations. Alright, so we can do this in Python, so let's do it. Alright, so I'm going to create a new one. Let's call this run examples.py. Import Tensorflow STF, and a is going to be tf.constant, let's say 3. B is going to be tf.constant of let's say 4. And so v is equal to, we need to define the session, right? Alright, so SESS is going to be tf.session run with a. So let me print v. Alright, so let's see. R and hit tab to autocomplete and hit enter. Now this should give us 3 apparently. Yep, this one. Now what we can do is we can run it with an input like this. So let's do this. A and B. If you do this, it should give me a list of numbers. Right. So this is how you run, how you call the run method. Let's go to the next slide. Alright, so this is an example of how to use the feed dictionary. Right, so let's go over this code. Okay, so this is defining my graph, and this is creating my session. This one is overriding tensor A with 15. Initially tensor A was addition of 2 and 3, which was 5. Now in here I'm overriding A with 15. So in my graph, this when I'm running this, A will be equal to 15, which means that B is going to be multiplication of 15 and 4, which is going to be 60. And this is how I run it. So I want to evaluate B, and this is the feed dictionary. So A is going to be equal to 15 over here, and then when I evaluate B, this is going to be 15 multiplied by 4, which is going to give me 60. So let's try this in Python. Alright, so okay, let me create from S feed example dot py. Right, so import Tensorflow as tf. Now I need to define my graph. A is equal to tf dot add of I guess 2 and 3, and B is equal to tf dot mul of A and 4, tf dot session. Now yes, replace dictionary is equal to A should be 15. Now I can just run. The first argument is going to be my tensor, which I want to evaluate, and the second argument is going to be the feed dictionary, which is this one. Now I want to print the output of this. Alright, so the name is feed dictionary example. It's located in the same place, so I'm just going to hit up arrow and then F and tab, feed dictionary example. If I hit enter, it should give me 60. Yep. Alright, so what's happening over here? I replace value of A with 15. So in here, A is going to be evaluated as 15. Multiplication of 15 and 4 is going to be 60, which is what we got. Alright, placeholder. Alright, so in our previous example, you may have noticed that the graph that we defined doesn't use the true input. It always uses some numbers. Let's go back to our example. Let's assume that these are my inputs. These might change by time, but my code does not accommodate that. So to do that, we can use placeholders for these inputs, and we can ask the client, ask the user, to give us these values instead of us writing these in our codes. So that's the application of placeholders for the input. Alright, so we create these placeholders using this placeholder call. This first argument is a type. The second argument is a shape. We've already covered the shape of tensors. And the last argument is going to be name, which is none by default. And default for the shape, if you don't give it a value, it will be considered as none, which means that it doesn't have a shape yet. Alright, so let's do this in Python. So let's go over the code first. So X is going to be a placeholder, and the shape is going to be, so it's a two-dimensional tensor, 1024 by 1024, and this is saying that there's going to be a matrix multiplication of X by itself, and the result will be stored in another tensor called Y. So we are going to run to evaluate Y, but this will give us an error. Why? Because we didn't feed X. So if you determine a placeholder, you should feed it in the feed dictionary as a second argument. So it should have been Y, comma, and a feed dictionary for X. So this is the correct way to do this. So sess.run Y and a feed dictionary. This will work. This is another example for the feed dictionary, which is easier to implement. So let's do this in Python. And this is example for placeholder. Alright, so I'm just going to create this one and save it as placeholder example.python. Right, import Tensorflow as TF, and I'm going to import numpy as NP. Right, so I'm going to create A, which is going to be a placeholder of type int32, and it's going to be a vector of length 2, and the name is going to be input. So let's do this. A is going to be tf.placeholder of int32 and tf.int32, tf.int32, and the second argument is going to be the shape 2, and the last argument is going to be the name. This is an optional argument. The rest is just defining the graph. So B is going to be reduce prod of A, and C is going to be reduce sum of A. D is going to be adding B and C. Alright, so B is going to be TF dot reduce prod of A, and it has a name, prod B. Let me copy this to create C, reduce sum of A and sum for C. D is going to be TF dot add B and C. And name is add D. Right, so let's create a session. Right, so we have to give it an input, a feed dictionary. Alright, so input dict is going to be an array of, this is my array, but I need to determine the type because in here I specified the type as int32. So this is how I'm going to create the feed dictionary. So input dict is going to be equal to A as np dot array, which this is my array 1 and 2, and then I need to determine the type np dot int 32. This should work. The type is equal to and now I can run to evaluate D with this feed dictionary. Alright, since let's run, I want to evaluate D, and what was, okay, feed dict is going to be equal to this input dict. Now I want to print the output. Now I want to run it, so it's a placeholder underscore example. Just up arrow and change this code to place and hit tab, hit enter. Alright, so I got an error apparently. This should be name equal. Alright, so let's try again. Another error. np.array. And let's try again. Alright, so this is the input that I got, and yeah, so this is how you use placeholders. Let's take a look at our result. So this is the placeholder, which is 1 and 2 A is going to be evaluated as 1 and 2, and then this is product, which is going to be 2. This is the sum, this is going to be 3. Adding B and C, 2 and 3 is going to give me a 5. What did I get? A 5. So looks good. Alright, so that's it for this video. In the next video I'm going to be covering variables. Please consider subscribing if you find these videos useful. Thank you.